Hi there. This is a video about triangle congruence, specifically the kind where we use this concept called SAS, which is an acronym for side angle side. So before I talk about the side angle side congruency theorem, let's just simply talk about congruent triangles. So what I have here is I've drawn two identical triangles. Now these triangles are considered to be congruent, but let's talk about what that really means. So congruent triangles means that all corresponding sides are congruent and all corresponding angles are congruent. So what I'm going to start with are my side lengths. Now if I look on my triangle here on the left side, I know that side length AB is my shortest side. If these two triangles are congruent, then that's going to be congruent to my shortest side over here, which is ED. If I take my medium side length, which is BC, that's going to be congruent to our medium side over here, EF. Now, the last one, I could say that AC is congruent to side length DF. All right, so I know that all of these things correspond, and the word correspond means same location. So that like the short side corresponds with the short side, the long side corresponds with the long side, and the middle with the middle. Now let's talk about the angles. So if I start off with angle A, that's in between the side length with 1 tick mark and the side length with 3. That's going to correspond with angle D over here, which is created by the side length with 1 tick mark and with 3 tick marks. And if I follow that same pattern, I can then say that angle B is congruent to angle E, and that angle C is congruent to angle F. All right, and so knowing that these two triangles are congruent, I can make all of these statements. Now, the most important statement comes from actually saying that one triangle is congruent to the other. Now, what I'm going to do is this. I'm going to write this out as triangle ABC is congruent to triangle DEF. Now, it's really important that whatever I start off my statement with helps me write this statement. Okay, number one, let's look at something. Let's look at about how A corresponds with D. Notice how these angles have one arc mark. These are congruent. Notice how if I start with A, naming this triangle, I have to start with D in this triangle. The same is going to happen for side length or angle B and angle E. Those correspond with each other. Angle B has 2 arc marks, so does angle E. So if I go AB here, then I have to go DE. And the last one is C and F. Okay, notice how C has 3 arc marks and so does F. And so that tells me how I name it. Now, I don't have to name it triangle ABC. I can really name it whatever I want. I could also say triangle BAC, but then if I say triangle BAC, then I have to say, so I did BAC, I have to do EDF. So I would have to name this triangle over here, triangle EDF. All right, in order for that to work. All right, notice how B corresponds with E, A corresponds with D, and C corresponds with F. So you can really name it whatever you want. All right, so the first thing I want to talk about is this concept of the side angle side triangle congruency theorem. And what I want to do, first of all, I never say side angle side. I always use the acronym SAS. All right, and here's what I want to do. What I'm going to do is let's first create a side length here, which we'll call JK. All right, and let's say that JK is 3 inches. Now, the next thing I want to do is create an angle measure that's, say, 40 degrees. All right, and from that 40-degree angle, I'm going to create this other point here, N, such that JN is 2 inches. Okay, now if I take this and I duplicate this exact same thing here to a different concept over here. So let's say that I make another line segment here, which we'll call SP, and we'll call SP 3 inches, and we'll make a 40-degree angle going up, like so. And then we'll create another point R that's 2 inches away from point S. All right, so we'll put R up here, and that this is 2 inches. Now, my drawing isn't perfect because I'm doing it freehand, but if we connect these triangles or these points here like N and K and R and P, what we've done is we've created two congruent triangles, all right? And so let's say this. Let's say that triangle KJN is congruent to triangle PSR, all right? So those triangles are congruent, and all I was given and all I told you to do, and what you can do is you can actually measure this out. If you have a protractor and a ruler, measure a length of 3 inches, create a 40-degree angle, and make another line segment that's 2 inches long, connect N and K together, and do the same thing over here for R and P, and you'll actually get two congruent triangles. All right, and think about what you were given. All right, you're given a side length, an included angle, and another side. And the same thing happens over here. You're given a side length, the included angle, and the other side length. And as I go around this triangle, all right, I can go clockwise or I can go counterclockwise, but it's going to read as SAS, SAS, or SAS. And that doesn't matter, how you look at it, but you're given a side, an included angle, and a side. And if that's the information that you're given, then you can draw the conclusion that these two triangles are congruent. You don't need to know what angle N is, or R, or K, or P. You don't need to know the length of NK and RP. What we just automatically know is that they're going to be congruent because the triangles are congruent. Okay, so one of the things that we do with triangle congruency theorems is we use them to do proofs, okay? So proving triangles congruent. And I want to go through just a basic proof on how you want to use the side angle side theorem to prove that these two triangles are congruent, all right? So the given information you have is that MR and KP bisect each other at point F. And all that information will do will lead us to the conclusion that these two triangles are in fact congruent. So let's set up, let's first just logically go over, this proof, all right? And so what I do is I use this given statement to draw some conclusions, right? MR and KP bisect each other at point F. So what I know is that I can come in here and say that KF is congruent to FP. And I can say that MF is congruent to FR. And I'm only making those statements because of the given statement, all right? These two segments bisect each other. And what that means is that they cut each other in half at point F, okay? And so I've got that information. The other information that I have is that this angle here, MFK, is congruent to the angle RFP, all right, because those are vertical angles. And I'm simply just using the picture to do that. From there, what I can see is that I've got a side, an angle, and a side that's congruent to another side, angle, and a side. And because of that information, I can automatically conclude that these two triangles are congruent. Okay, so what I want to do is actually go through the formal proof. All right, now I already did that with the picture, and whenever I'm doing a proof, This is the action that I go through. I think about it logically, and then I come over here and make my table with statements and reasons. All right, so the first thing I did was I put out my given statement, all right, that MR and KP bisect each other at point F, and that's given to you, all right? It's like Christmas all over again, okay? So the second statement I want to write is, what do I conclude from this information? All right, and what I did the first go around was I labeled the fact that KF is congruent to FP. All right, so I'm going to write that KF is congruent to FP. And that is the result of a bisector. All right, so let's call this a segment, let's do definition of a bisector. All right, is something that cuts something into two congruent parts. All right, and then the third thing that I could say was that segment length MF is congruent to segment length FR. All right, and the reason why I can say that is the same thing. That's a definition of a bisector. All right, and so, you know, that's what I'm using. I'm using the fact that that these bisect each other to draw these conclusions that those segments are congruent. All right, now the fourth statement that I can say here is that angle KFM, so angle KFM is congruent to angle RFP, okay? And I'm able to say that because those are vertical angles. Okay, so now that I've got those statements in there, then what that tells me is that I've got two different sets of segments that are congruent and their included angle. And what that allows me to do is to arrive at my proof statement, which is that triangle KMF is congruent to triangle PRF, and that's because of the side angle side congruency theorem. And this is the kind of stuff that we use with our congruency statements. All right, so it's not a whole lot of like solving equations and setting things up. It's more of showing that one triangle is congruent to the other. So I hope you enjoyed this video, and we'll talk to you soon. Thanks a lot. Bye.